Today, I talk about an implementation guide for cross-platform utilization, PHR utilization in Japan. I am Hisashi Osanai. I am engaged in development of health data utilization services at Fujitsu and a member of JP Core Development and PHR Service Business Association in Japan. I assume that you don't know the company Fujitsu, so I would like to briefly explain about Fujitsu in healthcare field of Japan. The share of Fujitsu's EMR is 32% for all hospitals, 59% for university hospital. According to the data of 2023, Fujitsu is EMR share #1 in Japan. So here is a definition of EHR and PHR in this presentation. EHR mainly refers patient medical records generated by medical institutions, and PHR refers to personal health information generated by self-input or self-measurement. The main point is where the data was generated. It's a point, I think. Here is a trend in EHR utilization in Japan. As a medical DX policy in Japan, Japanese government is promoting the EMR sharing services. The operation is planned to begin in April 2025. The service provides 3 types of EHR. One is, in Japanese, referral document and health checkup document, and 6, medical information. Medical institution send the file resources to the services after create and validate them from EMR. Then other medical institutions and people can obtain this data. JP Core is developed by JAMI. JAMI stands for Japan Association for Medical Informatics. So here is the IG, EHR-related IG certification process in Japan. First, developed by each organization, like JAMI, and then examined by Helix. Finally, certified as standard by mHealth. Regarding EHR, IG development for each use case, such as health checkup, discharge summary, and so on, are progressing with the certification process. Here is a trend in PHR utilization in Japan. Since 2015, research on PHR utilization models and data handling have been promoted in academia. Since 2019, establishment of guidelines, security measures, and personal info handling have been promoted in government. Since 2023, improving the business environment for the PHR utilization has been promoted in private. In recent years, PHR utilization has progressed rapidly. Here is the PHR standardization in Japan. The horizontal axis represents the member of composition. The vertical axis represents the establishment purpose. There are 4 major groups, but each group operates separately. So PSBA is developing the PHR IG in order to collaborate across the 4 groups. Here is the point of standardization to ensure interoperability. To ensure the interoperability between different systems, standardization of data access, data communication, and data format are important. Data format is further divided into the standardization of data types, standardization of terms, code, and measurement, and standardization of metadata. International examples such as mHealth in France, Kanta PHR in Finland, and MIJ in Netherlands has adapted FHIR for PHR exchange. Adoption of FHIR resolved standardization of authentication and authorization, standardization of communication, and standardization of data format. Here is the current PHR standard for mobile OS, Healthkit for iOS, and Health Connect for Android, provided as frameworks that realize the collection, storage, and sharing of health data and fitness data. As a PHR standard, we have OpenmHealth and Kanta PHR. Here is the relationship between standard from data perspective. We defined these data items as a minimum data set. Adoption of PHR standard resolved this part, standardization of data types, terms, code, and measurement, and metadata. Our approach for PHR-IG development is first develop PHR-IG with current PHR standard, then add items based on use case. The PHR-IG covers 341 data types, 14 code systems, and metadata. The IG is defined without inheritance to ensure global availability. So PHR-IG is located here, and the IG is currently being formulated as a standard specification by PSBA, but we don't have a certification process like EHR now. Here is the approach to standardize PHR. We have 4 steps. I will explain each step. You can see this figure. Most of PHR is a measurement of self-reported data. From FHIR specification, observation is intended for capturing measurement and subjective point-in-time assessment. Therefore, these data are intended to target for FHIR observation resource. But there are a few exceptions: nutrition intake, medication, and prescription. Here is the classification of data type. Data type are grouped by hierarchy, which represent data characteristics, level 1 and level 2. Profiles are created for each top hierarchy for level 1. So we created activity profile, nutrition profile, and so on. Some data type like body height, BMI have official profile in FHIR specification. For those data types, profiles are individually created to conform FHIR specification. Healthkit defines classes based on the characteristics of the data. For example, HK quantity sample class has 103 types such as steps, height, and so on. Here is the data structure of Healthkit using body temperature as an example. Data type is represented as identifier attribute. Data value can be obtained by specifying unit. Metadata common to all data type is contained in base class, and metadata specific to each data type is contained as key value pair here. Health Connect defines classes for each data type. There are 46 classes, such as active calorie burned, basal body temperature, and so on. Exercise session record class has 86 types in addition. Here is the data structure of Health Connect using body temperature record. Data type is represented as class. This is class name, body temperature record, and data value can be obtained by specifying unit in Celsius, in Fahrenheit. Metadata common to all data type is contained a metadata class, and metadata specific to each data type is contained in class attribute. Here is the data structure of OpenmHealth using body temperature. data type is represented as key of data value here, body temperature. Data value and unit are contained in a same object, and generation time is here. And metadata specific to each data type is contained in element. This case, temporal relationship to sleep. Here is the data structure of Kanta PHR. Kanta PHR has adapted FHIR, already adapted FHIR, so I don't skip the explanation. Here is the summary. We have data type, data value and unit, and metadata. So here is a basic of mapping common PHR data structure to FHIR observation resources. Data type maps to code, but data value and unit map to value quantity, metadata map to effect, date time, body site, and method. Data values are mapped to different elements depend on its type. For numerical data, such as weight, height, temperature, map to observation value quantity. For categorical data, such as symptom, maps to observation value codable concept. For sampled data, such as ECG, map to observation value sampled data. For compound data, such as blood pressure, I'll explain in the next slide. Mapping of the compound data depends on if values are separable or not. Separable means data that can be understood in independent context but related to each other. This case maps to observation has member. Inseparable means data that must be the same context to understand its meaning. So this case maps to observation component. Same concept data are mapped to a single code. We decided to use camel case in the code system. Code is sliced to allow having both PHR-IG code and international standard code, LOINC. This is slice. Yeah. If applicable, code in PHR-IG are bound to LOINC code. So we have 68 LOINC code now. The PHR-IG defines the unit to be used for each data type. Regarding unit definition, units are chosen based on standard conventions. In this case, millimole per liter for blood glucose. So then a unit must be converted to the defined one. So we define the millimole per liter in our code system, in our IG. So we people need to convert the unit. Here is an example of code and unit defined in PHR-IG. In this code system, code and corresponding unit are listed. The FHIR element to map metadata value is determined by its type. There are 2 points. First is source device application are very important for the data interpretation. The second one is mapping of data-specific metadata considered individually. It takes time. So here is the social implementation example. Fujitsu's Healthy Living platform harmonized PHR-IG into Healthy Living IG. So we integrate PHR-IG into our IG. And we are using PHR as key element in realizing data portability. The service will be rolled out to 30 hospitals in this fiscal year, so now 10 hospitals. Summary. In Japan, the standardization of PHR using FHIR is progressing, and PHR-IG have been developed. PHR-IG defined the data covered by the 4 standards: Apple Healthkit, Google Health Connect, Open mHealth, and Kanta PHR as the minimum data set. The social implementation PHR-IG is also progressing. International standardization PHR is crucial to ensure data portability using wearable devices across countries. So we aim to develop this IG that can be used globally. So anytime you can contact me and my colleague Sarkura. Yes, please. You can find the IG here. So any question?
Thank you, very interesting. I have a question regarding one of the first slides. I guess it stated that you depend on US core. Could you explain why, and why not have a Japanese core module profiles?
So if our PHR IG is subordinate to HL7 file, not JP core, because if we PHR IG, parent of PHR IG is JP core, so people have to harmonize to US core and JP core. It's very tough work. So it's better. So if we need to sync the IG for international, so the every IG should be under the HL7 file. So it's my understanding. It's tough work for harmonize. And so we have a similar activity. So we support mCode IG for oncology. So this is under US core. So we harmonize to, so our IG is under JP core, but so this US core to JP core is very tough work for us.
So it's for support of Apple Healthkit and Android Fire and all the international data exchange. So thank you. Yep.
Thank you.
Any more questions?
Yes.
Thank you. So you mentioned wearable devices. Is the goal for patients to provide data from wearable devices through PHR that can be then shared with the hospital?
Yes. So Healthy Living platform already done that kind of function. So we are the approach. My data I can share this data to through the EMR. So our Fujitsu's EMR. So it's possible based on the patient consent. Is patient allowed to share the data?
Hi, thanks for the presentation. So, I mean, looking at the slide, when you're going from Apple Healthkit to the PHR IG, at least from a first look, it seemed like the Apple Healthkit was a lot more granular and a lot. I was just wondering if there's any data loss going to FHIR or any challenges in mapping the data to conform to the FHIR standard?
So far, in Apple Healthkit, so we don't have a sample code, especially for activity. So the data name of data item is rugby or soccer. So, but we don't know what kind of data in it. But so in this case, it's very difficult to map. So we don't know the real data. But so we are strong for our background is health EMR. So we are familiar with the healthcare related data. So we can convert a map to the Healthkit to the FHIR.
More questions? Yes?
So thank you. I really like this diagram that you show how different IGs are overlapping. So imagine, so for example, look at the vital sign, right? Vital sign is inside.
That's okay. This is bigger.
Okay, thank you. So the vital sign is inside the PHR and JP Core, right?
Yes.
Does it mean that both of them they agree on the exact details of profile for that resource type, or it means that both of them they support that resource type, but they might have different, like required fields, different extensions? What does it mean, like when that specific resource type is shared between them?
So the meaning of overlap?
Yes.
Saruk-san, could you explain? So it's very difficult. So it's case by case. So we provide the PHR related profile, and so for blood pressure, and also EHR related profile for blood pressure. So profile is different, but under observation, but profile is different. But so it's case by case. But so it's both vital signs. So we match into one. Okay. Yeah, but so big difference is device information. If which medical device measure this value, so for wearable or as a real medical device, so we can recognize the difference. And so you need some kind of information we follow to the EMR related specification.
Okay, thanks for the presentation. So is there any open, I mean, the implementation made by you, is it open sourced or is it enterprise?
No, so we are, sorry. So we are open. So we already published this IG to the internet. So you can check this. But so in this IG, there are a lot of Japanese and English. We just translate Japanese to English. So to get many party for this activity. But there is no fish file on the GitHub so far. But we can do it.
Please do that.
Yes.
Are providers accepting of all of this patient-generated health data? And like, if blood pressure readings, for instance, were being sent and then there happened to be a series of high blood pressure readings, like, is the provider going to be notified, see them, do anything about it? Like, how are providers interacting with this data?
So Health Sharing Platform released March 2023. So we spent 1 year, but we are #1 email vendor, but it's very difficult to install the hospital because of the reason. Yeah, but so it depends on the sort of hospital, different hospital, but so Japanese government push this kind of direction. So many hospitals try to install this kind of software, not only Fujitsu.
Last question, anyone? Or no, we're good. Thank you.
Thank you very much.